Well, hello. Fancy seeing you here. We're going to talk about sums of fractions today. We're going to continue this trend, but what we're going to do is we're going to kind of build on the idea of where, like, we have been using, uh, we have been using this idea of like models, right? So I don't know, 2/3. Just kidding. I don't even want to do that one. Let's do. Oh boy. Oh boy. Let's do. Oh. My goodness. Disaster from the get-go. Let's do 1/10. Wow. Now I'm gonna make it hard on myself. And 4/10. Okay. All right. So what we talked about in the last video, now that I've gotten through all this chaos and glitching and whatnot, is oh boy. Is this idea that we were like, okay, well, I know that if my denominators are the same, right, that's going to mean that my model is cut into 10 pieces in this case. So let's see, tens, one down the middle, and then you do 4 on each side. 1, 2, 3, 4. Cool. So there's 10 pieces there. And remember, each one of these is equal to 1/10. Each slice is 1/10. So if we take our numerators in our numbers above, it's just going to tell us how many we need to shade in. So I could start with this one and say, okay, I need 1/10. So I'll shade in 1/10. And then we can go with this one. And that's 4 more tenths. So 1, 2, 3, 4. And if we count how many that is altogether, right, it's still the 10 pieces. And what we ended up shading all together was 5 of them, right? So that's what we were talking about, like how we use this idea of a model to do it. Now, or a tape diagram. I don't know. I just screamed a model. Really, it's a tape diagram. But regardless, what we were talking about at the end of the video, though, is we had talked about this idea that we started to notice that in all of our examples from that other video, is that our denominator isn't changing, right? It's really what's going on with our numerator that helps us. And so that's what we're going to talk about today is how can we explore this concept with that. So let's say we had 3/4 and we were adding 2/4. Okay. Well, technically speaking, we already know that it's going to be fourths. And then we can think about this idea that I'm really just adding my numerators. 3 plus 2, that equals 5. Or, right? So, or we could even think about that as that model. I cut into fourths. I need to shade 5. There's 1, 2, 3, 4. Oh, so I need another one. 5. So there's 5/4. And I know that this is equal to the number 1. So the other way I could write this, or, would be 1 whole, and then the 1 out of 4 that's left over. So 1 and 1/4. So those were those two pieces. So actually what we see here with adding our fractions is that really our denominators, denominators stay the same. And then we just add the numerator. And we might have to think about if we have more than one, if we have more than we need. I talked about that in the other video as well, like what happens when you have more than what you need. And we'll play more with that. So let's kind of do this. Let's do a few more. So let's say I'll just do some funky ones that maybe normally we wouldn't cut up. Like what if we had 3/7? I mean, we haven't even really talked about sevenths, and we add 2/7. Okay, well, again, remember our steps. The denominator we've seen has not changed. It just slides on over. And then I just add what's upstairs in my numerator. 3 plus 2 is 5. So I have 5/7. So 2/7 plus 3/7 equals 5/7, which again makes sense. If I have if I have 3 pieces and then another 2 pieces and I put them together, that's 5 pieces. Right? If I had oh boy, this is going to be trouble that I tried to do this. If I had a pizza, I like pizza, so I like to go to this one. And this is again why I always say do rectangles, not circles. And I had 7 equal pieces. Oh, I don't even know how to do that. There's 4. That's not going to work. Okay, wait. Oh, man, that weird glitch is still going on, huh? Let's see, 3, 4, 5, 6, 7. Oh, okay. Never mind. I'm gonna have to do a square pizza plus my screen's glitching. It's driving me crazy. So let's see. 1, 2, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So there's 7. And again, I was hoping they'd be equal, but these aren't really equal. 4. And I have 3 of them. And then I have 2 of them. Together, that makes 5 out of 7. Sorry, that was a really long, crazy explanation for something you already knew. Okay, so let's just keep playing. So again, adding fractions, we're going to keep the denominator the same. We're going to add the numerators. So let's go A. This is one of those opportunities you can just right away. Let's pause once I get these written down and try them out. What if I did a big one, 1700ths plus 3200ths? Ooh, okay. So pause this, try it out and see what we got. All right, so you paused it, you're back. Here we go. Rules state, denominator stays the same. Add your numerators. Done, 7/8. 3/8 plus 4/8 is 7/8. 3 pieces plus 4 pieces out of the 8 pieces equals 7 of the 8 pieces. Okay, 2, denominator stay the same. 3 plus 5 is 8. Boom, done. Okay, denominator stay the same. Add my numerators. Okay, well, this I gotta do on paper over here. I can't just. And we're gonna get 49. So 4900ths. And that's true. I mean, that would literally mean I would take a model and cut it into 100 pieces. And then I would shade in 49 of them, which is about half. That's an estimate, but yeah, that's what we would get. So there we go. Adding decimals on a nothing, just using a skill. We're not even using models. We're just saying slide the denominator over, add the numerators. So let's go back to that other concept now that this makes sense more for us about what happens when we get more than we need, right? So again, here's the skill. Slide it over, add the top. But now as you can see again, I have 8 out of 4, which really, I don't know. What does that entirely mean? So if it's 8 out of 4, I have more than I need. I can model this as my other way. I can think about how many holes that is, like total. So I'd make a model. I would cut it into 4 pieces. And this means I need to shade in 8 of them. So I'm gonna go 1, 2, 3, 4. So that's not enough. So I need a new model. Okay, so do that and shade those in. Ignore this weird glitch over in the corner. I'm just trying to get rid of them. 1, 2, oh, wait, so 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 out of 4. And actually what we realize here is that this is equal to the number 1, right? I filled the whole thing up. That's 1. This is also equal to the number 1. So if we add 1 and 1, 8 out of 4 is actually the same thing as 2. And that would make sense. Like I'll go back to even my soccer team analogy. We have 8 people that want to play soccer. A team can only have 4 people in it. So you would have 2 full teams playing soccer. Like that's actually pretty cool. It works pretty good. So of course we gotta do one more like that because I was like talking and then the glitches, they distract me and then whatever. So let's see. Let's say, oh my gosh, isn't that crazy? Let's say 3/5 plus 6/5. So that's already bigger than 1 right there. Okay, so again, denominator stays the same. Add my numerators. 3 plus 6, that's 9/5. Now, it's 9/5, or we can think about what makes a whole, right? One of the things that makes a whole it's not the glitch on the screen, is filling up all my pieces. So I would have 1, 2, 3, 4. So 1, 2, 3, 4, 5 pieces. So here's a fifth. I need to shade in 9 of them. Here, I'll even label each one like a tape diagram. Okay, now I know there's only 5 here. So I'm actually going to make another one because this is only 1, 2, 3, 4, 5, and I need 9. So here's my next model. We're thinking about the other way we can write this 9/5. So I need 9 of them. So here's 1, 2, 3, 4, 5. So that makes 1, 6, 7, 8, 9. So what's left here is 4 out of the 5. So 9/5 is also 1 whole and 4 out of 5. So those are the 2 ways we can think about that. And we're going to explore that more. I don't want you to worry about it. I don't want you to feel confused like about that concept. But I do want us to understand that adding fractions as an algorithm is pretty straightforward, right? You're going to take your denominator and you're going to keep it the same because that's what we want. They have to be the same pieces, right? And we're going to study that. So really don't worry. Every fraction you're going to see during this time, the denominators will be the same. We will look at different denominators later, but for now, denominator is the same. So it slides over. And then we just add our numerators. 3 plus 1 is 4. So it's 4/5. So there's our algorithm for solving the sums of fractions. So that's it. That's all. That's all I got. Keep up the good work. Again, keep asking questions. If this is confusing, ask questions. I don't blame you if it's confusing. I have glitches on the screens. I spaced out a couple times. I tried to draw a pizza and it didn't work. Like, yeah, I get it. So if you're unsure, remember in class, ask questions, pull it together, raise your hand, be like, yo, give me another way of doing this. And that's our job. We'll take care of that for you. So appreciate your hard work. We'll see you soon.